In this video, we'll take a look at a HRSG. I'll show you all of its main parts, how it works, we'll discuss the different designs that are available to us, and I'll show you how it's used within a combined cycle power plant. Here's our HRSG again. This time though, I've taken a cross section so that we can see the interior parts of the HRSG. Don't be worried if this looks a little bit complicated. There's a lot of colours, but there's also a lot of repetition. Let's start with the basics again. The gas turbine is sending hot exhaust gases into our HRSG, which won't actually look like a large empty space. There are heat exchangers inside. The design of the HRSG will really depend upon what you're going to use it for. If you're only going to require about 10 or 15 bars of steam pressure, then there's no point installing a HRSG that can operate at 200 bar. As pressure and temperature increase, so too does cost. In the past, people took those waste gases and all of the heat energy they contain, and they discharged them directly through a stack, like this one here, and all of that potential heat energy that we could have harnessed or recovered was lost. Nowadays, that is not commercially viable. It's too expensive just to waste that large amount of heat. So we're going to need to recover it. We add the water on the right side of our HRSG via the economizer. After that, the water flows to a steam drum. Some of that water flows downwards into an evaporator and then back up again to the steam drum, and we will produce steam. The reason this occurs is because as the exhaust gases pass across the heat exchangers, the water absorbs some of the heat from the exhaust gases and begins to turn into steam. And we use deaerators to remove dissolved gases from the water, which reduces the likelihood of corrosion within the system. Dissolved gases may be oxygen or CO2, which we can also remove chemically, but we tend not to do that unless absolutely necessary, because the chemicals that are used to remove CO2 and oxygen are quite expensive, and they will be typically dosed into the steam drums. We don't want condensation forming within the stack, the inside surfaces, which we can see now, because if we get condensation on these surfaces, it's likely to become corrosive. The condensation becomes something similar to acid rain, and so we don't want water mixing with our exhaust gases within the stack.